Since we have already seen the different types of activation function and the popular derivations of it, then now we are going to build a step ahead in building a particular neuron model, that is design of output layer. Now I already taught you about activation functions when you are, and I also told you about which activation function is suitable in the hidden layers. Today we are going to talk on output layer. Okay, so let us discuss the design of the last layer of a network in particular, which is the output layer. So in addition to all hidden layers, it completes the functions of dimensional transformation and also feature extraction, and it is also used as an output layer. So these are all the functionalities of an output layer. What? Dimensional transformation, feature extraction, and then producing you with the output. So it is very necessary that you decide which type of activation function and what type of activation you are going to use depending on your specific application or task. So we are going to classify the discussion based on the range of output values. How do you want the output of your model to be? Based on that, we are going to select our activation function. So suppose if our output is in the range of 0 to 1 interval, then we are going to use a separate thing. So where do you use 0 to 1? Especially in the problems like image generation, in binary classification. So in that case, you will require only to add a sigmoid function. So simply you can use a sigmoid function after the value of output layer, so as to translate the value of the output into a probabilistic value. So how would be your output? Output you received at your output layer, but after passing through sigmoid function, you will be writing the output as P of x, which is nothing but an output, probability of that particular class of output, and or else it can also be not the probability of that class, that is 1 minus 0. So you can see for this particular case that I have been discussing, the neuron model will be like this. There will be some hidden layers which you are not bothered. After you calculated the output, all of these go to a single node wherein the activation function is sigmoid and it produces the output. Or else you can keep two nodes at the output and you can say that this was class 1 probability and you can say this was probability that it is not class 1. So I am putting it with a bar. So any of these things is okay. So if you have got an interval of 0 to 1, then you can very well go with a sigmoid function as an activation function for your output layer. Now going to the next one. Suppose I am going for 0 to 1 interval, but you have more than 2 categories and overall sum of these probabilities will be 1. So 0 to 1 interval with a sum of 1. Now for that case, the output value I am going to write that as OI. Okay na? So I have multiple outputs. So for that case, when the output OI again is in the range of 0 to 1, okay, but the sum of all these output values is going to be 1. So where do you find this problem? This is found in multi-category classification. So for this, you are going to use an function like this. So you have got your input layers, hidden layers, and based on how many categories, that many nodes you are going to keep in the output layer. So here I am choosing 3 categories. So it is like probability of output being A conditioned on input X. Similarly, probability of output being B and probability of output being C. When you add these probability, of course, the sum of probability is going to give you 1, right? So in that case, it is always suitable that you choose softmax function for your output layer as an activation function. Okay, so we always go for a softmax function for multi-category classification in your output layer, that you have to keep in your mind whenever you are designing a neuron model. So if it is a binary classification for the range 0 to 1, go for sigmoid. If it is 0 to 1 with probabilities being 1, that is you have multi-category, multi-classes of output, please go for softmax function. Next. This is the softmax function. I would like to little highlight this. So softmax function can not only map the output value to the interval of 0 to 1, but it will also satisfy the characteristic of probability that the sum of all the output values, the probability of the output is going to be 1. So you are going to see here for what is the probability of the output when you have got input as 2.0, it is giving you 0.7. For the second class 0.2, for the third class 0.1. Clearly the majority is with the class 1, and when you add the output values, it gives you to the value of 1.0. This is the mathematical expression I already discussed for the softmax function. So you can see very beautifully, depending on various number of classes, it is adjusting the probability within the range of 0 to 1, and it is also giving you the output value, output class based on the majority probability. So that's how softmax function plays a very important role when you have multi-class category classification. Now the next interval that we are going to see is -1, 1. So if you really want your range of output values to be distributed in an interval of -1 to 1, then simply you can go for tan hyperbolic activation function. Now this is mainly used in hidden layers. Now the design of the output layers has a certain flexibility. Not only hidden layers, even in output you can go for tan h, provided you know the output range is in the range of -1 to 1. So you should know your model better to use suitable activation function. So the design of the output layer has a certain flexibility, that is, it can be designed according to the actual application scenario and make full use of characteristics of existing activation function. So I would like to say, you just check what is your range of output and then you can use a suitable activation function. So this was all about where and how to use activation functions in the design of an output layer.